lot of discussion has gone on about what type of fuel will be used to transport us in the future. To give the world a more sustainable and greener environment, every bit of whatever type of fuel we decide on must be used to its fullest potential. Cutting-edge computing hardware and software have been donated to EcoCAR so that engineering students can experiment with different technologies.
The bottom line is college students would like to learn about the state-of-the-art instrumentations like the ones that dSPACE provides, because when they get jobs in industry, it's the same equipment, the same sophisticated tools that they'll need to operate in their jobs in the future.
So for the past few months you've been working on HIL. What exactly is that?
HIL is hardware in the loop. And so to us, it really just looks like a big box. But what it is it's a system that lets us kind of simulate what's going on in the vehicle. And then we don't actually have to have the vehicle to still be able to run tests. Say you're in your vehicle and you push on the accelerator pedal. Then it makes your car go faster, right? Well, we can simulate that in this box. So we can tell the box that we want the car to go faster, and then it will tell us how the vehicle responds, and then we don't actually have to have a real car.
So if once upon a time it was possible by metering air and fuel through the carburetor, through jets, and with little screwdriver adjustments, adjust the mixture so that the engine would run properly, today we need sophisticated electronic controllers that measure the amount of air going into the engine, meter the amount of fuel very accurately, and also measure the concentration of oxygen in the exhaust gas. Now, depending on how the engine is operated, whether you're going through an acceleration, whether the ambient temperature is hot or cold, whether you're at altitude or at sea level, all of these adjustments require an enormous amount of calibration, which are of course carried out automatically in the microcontroller, but someone has to somehow develop the algorithms and the calibrations that are going to make the engine work this way. The use of hardware-in-the-loop tools allows the engineer to actually, in advance of doing any experimentation, test the operation of a microcontroller through this real-time simulation of the engine, so that if one has a computer model of the engine, it is possible to predict all of the behaviors of the engine and to actually properly calibrate the controller so that even before the engine is placed in the vehicle and the vehicle has been driven a single mile, the controller already has the algorithms and the calibration that are needed for the vehicle to operate properly. And of course, engineers will then have to empirically, experimentally adjust some of these calibrations, but the hardware-in-the-loop hardware makes it possible to take a shortcut of several months in the development of a control strategy for an internal combustion engine.
I've gotten a chance to learn so much, and I'm really excited about what I'm learning about and excited about being involved in this program to be able to learn about a lot of different things. Not only are we learning about cars, but we're learning about alternative fuels and about collaborating with other programs and other teams, learning about working with the media, and so that's all been really rewarding too, just to be in an interdisciplinary program and be able to work with a lot of different types of people too, not only engineers but also other students that are maybe in the business school or other schools, and so that's been really rewarding as well.